Morning 9th standard. So our next topic is on Newton's first law of motion. So till your last 3A, you've been studied about what is a force, what are the types of force, that is contact and non-contact force, and in that about friction. So here we'll be learning about Newton's laws of motions. So the first question which should come in your mind is, how do objects are able to move, why they are moving? Okay, so in all your second lesson we were learning about your linear motion. So in an object which is able to move in a straight line, we call them as your linear motion. So our question is how they are able to do that. Okay, so how it is possible for them to move in a particular straight order without changing its position or without changing its direction. So all these answers can be given by your Newton's law, and this one is given by your Newton's first law of motion. So some of the examples is given here. So to move a cycle, the cycle has to apply a force in its pedal. So once if you apply a force, then the cycle will move. So if you are not applying the force, the cycle will be in a standstill position. If you are going to make a cycle to stand properly, it will stand, or else it will fall down. So whatever position it is, it will be in the same position unless and until you apply an external force. So examples are given here. So for your everyday life experience, okay, for everyday life experience, if you want to move an object, some external force is supposed to be acted upon it. Okay, you have to apply some external force. If there is no external force, the object remains to be in its state of rest or state of motion. Okay, it will be remaining in the state of rest or in the state of motion. So based on that, we'll be learning two concepts here. One is inertia, the other one is force. So I told you, now consider a cycle is going to be standstill. It will be in the same position. If at all I apply a force, if I apply the pedal, now what will happen? Yeah, if I press my pedal, the cycle starts to move. And if I'm going to continuously do that, the cycle will be moving. If I'm going to stop, the cycle will also stop. So if a body is in its state of rest, it remains to be the same state unless a force is applied on it. If you want to change it, you have to apply a force. If a body is moving, it will continue to move in the same speed, in the same direction, unless a force is applied on it. So you're going in a straight path in a cycle, you will go in a straight path. But I want to change. Now what will I do? I have to change the direction of my handle. So until I apply some extra force or until I apply change in direction, there will be no change. Okay, there will be no change. So two concepts we'll be learning it. One is called as inertia, the other one is force. So this was first discussed by Galileo, so it's called as Galileo's laws of inertia as well. Yeah, so according to Newton, so this is your first law. I want every one of you to memorize this. Okay, so according to first law of motion, if a body is in a state of rest, or it will remain in the state of rest, and if it is in the state of motion, it will remain in the motion in the same direction with the same speed unless an external force is applied on it. You take a book and leave it on the table, it will be there for a long time, even a years may happen. Unless you touch or unless someone moves the book, it will be there as well. Similarly, if you are going to pedal a cycle in the same speed, it will not change its speed or its direction. But if you want to increase the speed, you have to pedal fast. If you want to change the direction, you have to change its handle. So all this is called as your inertia. Inertia is the tendency of the body to be in its same position. Okay, to be in its same position. So as I told you, we'll be discussing about the qualitative discussion. What are the two qualities you can come from your Newton's first law? One is your definition of inertia. So definition of inertia and definition of force. So in the definition of inertia means, you can see here, according to which an object cannot change its state by itself. It cannot change. Okay, an object which cannot change its state by itself, but what it needs, if you want to change it, you need to apply an external force. The object will be in its state of rest, it will remain in the state of rest. If it is moving, it will be in the same moving in the same direction. but if I want to change it, I have to apply a force. So if you want to change inertia, what you have to apply there? Force. So inertia means it will be as such, okay, it will not do anything. The property of the body by virtue of which it tends to remain in the state of rest or motion is called as your inertia. Okay, inertia is the property, it is an inherent property of a body. Next one is definition of force. The second part of your Newton's first law, it's about your force. So force is the external cause which can move a stationary object or which can change the state of a motion of a moving body. So force is an external object, okay, it's an external cause. It's an external cause. If you are running, if someone comes and hit at you, you will not fall. Until that, you will run carefully. If someone is going to come and push you, you will not fall. So that is called as your force. So we define force as an external cause. So inertia is an inherent property and force is your external cause. You will be getting questions like which is or dash is your external cause. So the answer will be force. And which is the inherent property of an object means it is your inertia. So inertia means it is a tendency of the body to remain in its state of rest or in motion unless and until an external force acts on it. Okay, so if you are going to walk, unless you think if you want to stop, you will be keep on doing it. If at all, if some person comes and tries to fall on you or push or pull, then there is a change. So that is your force. So there are many examples given. A book lying on a table which will remain placed at its place unless it is displaced. Similarly, a ball which is rolling, it will keeps to roll, but the force of friction we saw in your previous chapter, frictional forces, there are many frictional forces like static frictional force, rolling frictional force, sliding frictional force. So depending upon the object and the surface, any of these frictional force will act upon the object, by which the object experiences an external force, so it tends to stop. So the ball which is rolling is in its inertia of motion. It is in inertia of what? Motion. Now the surface, if it is going to be horizontal, it will produce you a if the ball is rolling actually, so what kind of friction it will produce over there? Rolling friction. So rolling friction force try to hold your object, so eventually the speed in the ball decreases, by which the object tends to stop. So initially there was an inertia of motion, and the next one which came into it was your force of friction, so by which the ball tends to stop. So look at this. So let us consider this to be as our surface, a normal surface, and we will take a ball which is rolling on this surface. Okay, it is actually rolling. So initially if it is rolling, which means it is in the inertia of motion. So now what happens, there will be a friction between the ball and the surface. So this is your frictional force. So because of this frictional force, what will happen? The speed of the ball will decrease, by which the ball tends to stop. Therefore this is initially it was in inertia, and this is your external force by which the ball has stopped. So we also saw what is a force. Force is an external agency which is going to act on an object. Now imagine there is a book, and the book is being pulled by two boys who's having same amount of force. Now what will happen to the book? Will it move to the one or another? No, it will not move. Why? Because the sum of forces here will become 0. Okay, two boys who was of equal strength is going to pull the book in each direction. Okay, they are going to pull it towards themselves. But what will happen in both the cases, since they are going to apply the equal force, there is no motion in your book. Therefore the net resultant in that case we call as your 0. So why we call that is it is 0? Because your force is a vector quantity. Your force is what quantity? It is your vector quantity. Listen, you are going to have a book or an object. Okay, you'll be having a book like this, and you'll be having an object or an object like this, so one person is going to pull in this direction, the other one is going to pull the book in this direction. So let me consider this is also 5 Newton and this is also 5 Newton, but force is your vector quantity. So if I take this as positive, this should be negative. Therefore, sum of both the forces will be 0. So the book does not show any motion. So the sum of forces on an external object can also be 0. So imagine there are another two forces which are going to act on us, like this, like this. They are also going to be same. So if this is 5 Newton and this is 5 Newton, let me take this as positive and negative. So the total sum acting on the object will become 0. Why? Because they are equal and opposite to one another. Okay, they are equal and opposite to one another, by which they cancel off. But if they are not equal, the book will move to the direction in which there is more force. So the example, okay, same, we'll take an object like this. One is pushing with 10, okay, pulling away with 10 Newton, the another one with 7 Newton. Therefore, if you subtract this, okay, so let me take this as positive and this as negative. So which is having more force here? 10 Newton. So 10 minus 7, 3. So obviously the object will move towards this side. Okay, so if at all the forces is going to be equal and acting in opposite direction, therefore the sum of forces will become 0. So the next one is mass and inertia. So I know inertia is an inherent property, but whom does it depend on? What it is all about? So inertia depends upon the mass of the object. More the mass, more inertia. Imagine I'm going to keep you 10 books. You can easily move the 10 books, but if at all I'm going to keep some 100 books, okay, is it possible for you to lift it or move it? You cannot do, because the mass is increased. The mass has been increased. Is it very easy for us to lift a small stone? But it is not possible for us to lift a bigger massive stone. That is not possible for us. So inertia depends upon mass. So more the mass it is, you cannot change its inertia. Okay, a very big rock, all these will be in a standstill position. So for a normal person, you cannot roll it or push it easily. If you want to move it, you have to apply some external force which must be massive than this. So inertia depends upon the mass of the object. More the mass, more inertia. So it's given inertia as the inherent property of the body. It is a tendency to resist its change in state. If it is going to be in the state, it will be in the state. So it's like you don't try to change my state of rest or change of motion. So it will be in the same state. So the greater the mass, greater is the inertia of the body. So here they have given some of the example. So look at the second example. It is difficult to set a loaded trolley motion than an unloaded trolley. Similarly, it is difficult to stop a loaded trolley than an unloaded one. Yes or no? So if you are trying to stop a loaded trolley, some other way we will get hurt because of the mass in it. So if you are trying to stop it, it was in what inertia? It was in inertia of motion. So all these depends upon the mass of the object. Therefore, you can classify your inertia into 3 categories, but here they have given 2. Actually we have 3, that is inertia of rest, inertia of motion, inertia of direction. The object is in rest, it will be staying in the same position of rest. That is inertia of rest. The object is moving in one motion. Okay, if it is going in a straight line, it will be going in the straight line until an external force acts upon it. That is inertia of motion. If the object is in particular direction, okay, I'm going to go in a curvilinear motion or in a circular motion. If it is in one particular direction, it will be in the same direction unless an external force acts on it to change in its direction. So all these are your inertias, different types of inertia. But in our book we'll be learning inertia of rest and inertia of motion. So many examples have been given accordingly. Your question will be, they will give one particular question and ask you to state whether it is an inertia of rest or inertia of motion. So it will be as simple as such. Or they will ask you, give any two examples of inertia of rest and inertia of motion. So let us see. When a train suddenly starts moving forward, the passenger standing in the compartments tends to fall backwards. Why? Okay, so imagine you are sitting inside a train. Actually, who is moving? The train is in motion, but the passenger is in inertia of rest. So what will happen? He will go forward and come back, which means the person tries to be in the inertia of rest. He doesn't want to change its inertia. So this is an example of your inertia. So you can see when a hanging carpet is beaten with a stick, the dust particles starts falling out of it. Yes or no? Okay, imagine you will be having the carpet hanging. Okay, I'm not going to place a carpet. Imagine it is hanging. You know how it does, it will hang. Or imagine a screen which is hanging. Can you see a screen which is hanging? Now it is hanging, it is in inertia of rest. Now there will be dust particles in it. Yes or no? You will be having the dust particles like this in it. So now what I'm going to do, I'm going to beat. If I beat, this particular screen or the carpet will move backwards. It will move backwards. So this carpet will try to move a little bit backward to this position. Now what will happen to this dust particles? They does not have anything to hold on. So eventually they will fall off because they are inertia of rest. They are not going to stick with the carpet and move backwards. They are going to fall from that particular carpet. So it is because of your inertia of rest. The next example, on shaking the branches of the trees, the fruits fall down. Same. If you shake the branch of the trees, the branches are moving, not your fruits. So they eventually try to fall. So the reason is when the stems of the trees are shaken, they come in motion, while the fruits, due to inertia, remain in the state of rest. Now, I want to emphasize one thing. The students used to write it is because of inertia, but you have to mention whether it is inertia of rest or inertia of motion. So that point should be clear. So you have to clearly mention whether it is because of inertia of rest or inertia of motion. So on striking the coin at the bottom of a pile of a carom coins with a striker, lowest coin only moves away while the rest of the pile remains intact. So all these things you would have been doing as a funny part. Okay, while playing you'll be making only one coin which is at the last will be moving because all others in the inertia of rest. Similarly, you would have been seen this example that figure 3.7. You will have some coins. If you flip the card, the coin will eventually fall down because I'm just trying to move away the card, not my coin. So it should be done very fast. Okay, if you do slowly, the coin along with the card will come, but actually I want to take away only the card, so I have to move it very fast, by which the card comes up along with me and the coin falls into the tumbler. So when the corridor train suddenly starts, this is one of the important point and it's a repeated question all the time. So when the corridor train suddenly starts, the sliding doors of some compartment may open. Okay, so if it is going to start, the train isn't actually in motion, but the doors are trying to be in the inertia of rest, so they tend to open. Okay, the reason is the frame of the sliding door being contact with the floor of the train along also comes into the motion of the starting train, but the sliding door remains in its own position, so by which it tends to open on it. So the next one is inertia of motion. I told you already, if object is moving, it will be moving. It does not want to change its position. So let us see some of the examples. Best example, the second one. When a passenger jumps out of the moving train, he falls down. Why? Because he is inside the train. His whole body was in state of motion with the train. On jumping out of the moving train, suddenly he puts his body to inertia of rest. So our body cannot act to it, by which we fall down. So on jumping out of the train, as his feet touch the ground, the lower part comes to rest, while the upper part is still in its motion. So as a result, he will fall down in the direction of the train, not something opposite. Okay, so don't try all these in home. So all these when you go outside, there are, it is something, so it can cause some fatal things also. So don't try. Instead, you can observe all these in your news and all. It might come. Next one, when a running car stops suddenly, the passenger tends to lean forward because the object is in inertia of motion. If you put a sudden brake, it is coming to inertia of rest. So by which the passenger default he will come and fall forward. So all these are your inertia and types of inertias. So I want you to read all these examples because each example is like a different question. They'll give the condition, ask you to state what kind of inertia. Is it of rest or it is of motion, or they'll ask you to explain it with the answer. So better go through everything.